Normally I'd have an introduction here, but we're just going directly from here, from the previous session to this one. Um, okay, there are going to be two parts to this deep dive. The first part is going to be Amazon SageMaker Studio, a peek at Studio itself, and the way it provides integrated machine learning tools in a single interface. So Amazon SageMaker Studio is one component that you have as part of the SageMaker support for machine learning operations. And then we'll dive directly into the automation part, the practical part for SageMaker MLOps, the ability to do end-to-end. So first off, let's take a look at the big picture of Amazon SageMaker. At AWS, we're innovating on behalf of our customers to deliver the broadest and deepest set of machine learning capabilities for builders at all levels of expertise, removing undifferentiated heavy lifting so that our customers can move faster. By working together, these capabilities provide a way for developers and data scientists to focus on what really matters, building accurate, high-quality machine learning models which solve the business problem and improve over time without all the undifferentiated heavy lifting. SageMaker removes the muck of building machine learning and only leaves the diamonds. With capabilities like Data Wrangler and Feature Store and Clarify and the ability to create SageMaker pipelines and also the ability to do debugging and profiling of training as it's happening. It's never been easier to build, train, and deploy machine learning models in Amazon SageMaker. So Data Wrangler, by the way, is typically to get the data ready for a machine learning model. This is this part here. Data Wrangler, you'll see, is a no-code approach to letting you obtain data and transform it following a library of transformations. Or you can go to low-code approach and add in some small Python scripts yourself for doing transformations that are particular for your own need. Data Wrangler can select data from multiple data sources, such as Athena, Redshift, Lake Formation, S3, and SageMaker Feature Store. Previously, you'd need to write code to transform the data, but as I said, Data Wrangler provides a library of more than 300 pre-configured data transformations. So you can transform your data without writing a single line of code, unless you want to, or your application needs. Another aspect that I mentioned is Feature Store. Now, people ask why a feature store? What is a feature store? A feature store is a place where you store the data that you've processed through Data Wrangler. And the question is, why would you need a feature store? Well, the main reason for this is feature store is what guarantees that you will get the same features in production as you had when you were deploying your model. And so with the feature store, you have one place that provides this glue to deployment. Feature store, whether you're using SageMaker Feature Store or some third-party feature store, is a key part of connecting the data that you're using during training to the data you're receiving with your models in production. So with Feature Store, you can securely store, discover, and share features that you don't need to recreate the same features for different machine learning operations. And it serves features in large batches or in either for model training or serves features with single-digit millisecond latency for inference. And so it does the work to keep these features in sync and consistent. So let's take a look at SageMaker Studio. You have access to a purpose-built integrated tool for every step of ML development, including labeling, data preparation, feature engineering, bias detection, AutoML, training, tuning, hosting, inference explainability, debugging, and monitoring. Amazon SageMaker Studio helps data scientists and developers to build, train, and deploy ML models quickly by bringing together a broad set of purpose-built ML capabilities under a single pane of glass. Amazon SageMaker Studio is a web-based IDE for data scientists and developers to help build, train, and deploy machine learning models using a broad set of ML capabilities. These ML capabilities are enabled through a rich set of tools to help you with preparing data, storing features, building and training and tuning models, and deploying and monitoring those models. These tools are built as modular components and delivered to you through Amazon SageMaker as a managed service. As these tools are modular, it's possible to pick and choose the tools that you need for an ML problem. For example, you can bring your model trained in some other environment into SageMaker for deployment. Later on, we'll dive deep into these tools and we'll demonstrate how they can help you with your end-to-end ML lifecycle. One of the core features of Studio is the Studio Notebook. So let's see what features it offers. You can use Amazon SageMaker to do data processing, analytics, and machine learning workflows in one unified notebook. This notebook follows the practices or is basically Jupyter Labs improved and augmented to be able to take advantage of Amazon SageMaker. Customers told us that they don't want to have to switch between multiple platforms and tools for preparing large amounts of data and building ML models. So we now have EMR integration into SageMaker notebooks so that you can use Elastic MapReduce directly to create the features that you need for machine learning. And SageMaker notebooks now have Spark, Hive, and Presto running on Amazon EMR clusters and data lakes running on S3. With SageMaker Studio, you can browse and query data sources, explore metadata schemas, and start processing jobs for analytics or machine learning workflows. You can code using your preferred framework to build, train, and deploy machine learning models, all without leaving the universal Amazon SageMaker Studio notebook. So SageMaker Studio Notebooks supports elastic compute where you can dial up and down your resources. For example, let's say you started with a notebook with a T3 medium instance and later realized that for local development, you needed to have an M5 large. Then you can easily change that. Studio is also customizable. It comes bundled with a set of default images for running on your instances, but you can build your own image and bring it into Studio to customize your notebook experience. You can also install your own packages and extensions for additional customization. You can also automate customization with notebook lifecycle configurations. These are shell scripts triggered by Studio lifecycle events, such as starting a new Studio notebook. With that script, you can install custom packages, configure notebook extensions, set up source code repositories, shut down idle resources, and save costs. With a single click, you can share your notebook along with its dependencies to your coworkers for collaborating on a project. We also support native integration with Git for collaboration. Studio Notebook is integrated with various ML tools to help build and run data transformation and ML workflows in performant runtimes. So let's take a peek here at what uh, Studio looks like. So here we have SageMaker Studio, and I have this set up in my personal account. Although when we come to this, we will be running these notebooks. We will be running notebooks in individual accounts for you. And so let's take a look at the big picture. So the big add here from SageMaker Studio is the ability to let you manipulate data with Data Wrangler, Feature Store, or create compute clusters for managing data. The ability to create auto ML jobs so that you don't have to choose the particular algorithm or featureization approaches you're going to use for solving your business problems. There'll be experiments that will let you handle model lineage so that you know the sources of your models. We'll take a look at this. There are SageMaker pipelines that are complete end-to-end automation, including pulling in data, creating features, doing model training, including using AutoML pipeline steps, doing model evaluation, and then conditionally doing model registration. So once you have a model that's needed, that's where the model registry will come in, where you register a model for deployment. But before you do that, you can also do a number of things with models. You can share them. You can run an inference compiler to optimize your model for inference, or you can repackage your model for edge. And in Studio, you can also see the deployments that you've already created. You can take a look at the endpoints where you've deployed models. You can also manage edge device groups. There is also a key feature called SageMaker Jumpstarts. SageMaker Jumpstarts let you see pre-prepared solutions so that you can create immediate solutions. These are accelerators that will let you solve typical use cases such as demand forecasting with deep learning or other capabilities, such as, for example, document understanding. Now, these days, this also includes foundational models that have become important for doing large-scale machine learning. So the other things that are brought in are more common for Jupyter Labs. So there's the ability to take a look at your current file system. There's the ability to work with Git. And then there is the ability to do enablement, SageMaker development. So what extensions you've installed in SageMaker. And then let's get back to presentation. Okay, so that's basically what Studio will bring you. So now let's do a deeper dive into the end-to-end capabilities that SageMaker MLOps brings to you. Here's that big picture. that shows all of the SageMaker components that you can use for MLOps. This includes tools for data preparation on the left, that is SageMaker Data Wrangler, Processing Job, and Feature Store. This includes the ability for training and tuning models, so you can create SageMaker training jobs or SageMaker model tuning jobs that train a model for you using different hyperparameters. And then you can evaluate your model using SageMaker processing jobs or SageMaker transform jobs for batch processing. In here, you can use SageMaker Clarify, which is a tool that will let you know model bias and will let you explain the predictions of your models. There's a big part of SageMaker experiments that let you do experiment tracking and model lineage. Finally, when you have the models that you believe are ready for production, you can put them in SageMaker Model Registry to be ready for deployment, along with the various metrics that identify the performance of your model, the model's purpose, and so on. Once you have registered models and you're ready to deploy them, you can then do a variety of SageMaker deployments to target environments. We'll take a look as to your options for SageMaker deployments. Importantly, once you deploy a model to a SageMaker endpoint, you can take advantage of the SageMaker Model Monitor. The SageMaker Model Monitor will let you track your the data using an inference and compare it to the data and predictions you had during training, so that you can find out if your model is receiving the data that you expected it to receive. And if it's not, then you can retrain your model, or that your model is performing and producing the results that you expected. So you'll get some metrics that come out of SageMaker Model Monitor that will let you take a look at that. All of this is built on top of the AWS infrastructure. So S3 buckets, feature stores, data processing code built in, put in code commit, training code, and of course, our own places for taking a look at metrics. So another aspect of SageMaker MLOps is going to be projects and pipelines. Today, we're not going to be looking deeply into projects. We will be looking more into pipelines. So a key part of MLOps Ready, the MLOps Ready features, is the ability to bring in automation triggers. And so you can have, from SageMaker Model Monitor, it can output metrics that can cause a pipeline trigger to come in to restart your pipeline for featurizing your data, training and tuning models, and registering those models. And there's also the ability to monitor the code in code commit, or also in GitHub, in Git repositories. You can have source and version controls so that when you, say, for example, update your data processing code, you can automatically retrigger a model, build and train, and deploy. So let's take a look at these particular parts. So the first part that we have is SageMaker Data Wrangler. As I mentioned before, SageMaker Data Wrangler is a no-code to low-code environment that lets you work with raw data from multiple different sources and lets you apply to it data processing code and store the results of that data processing into features, and then also create training, validation, and test data sets. SageMaker processing jobs are the next step where you can include the results of Data Wrangler into a SageMaker processing job. It can be used for both structured and unstructured data. With processing, you can use a simplified managed experience on SageMaker to run your data processing workloads, to do feature engineering, validation, model evaluation, and model interpretation. You can use the Amazon SageMaker APIs during the experimentation phase and after the code is deployed in production to evaluate performance. If you have a large amount of data, SageMaker processing jobs can run in a distributed processing mode so that you can specify an elastic number of computes to process your data quickly. This, by the way, is not the EMR elastic MapReduce feature that I was mentioning before. This parallel processing would be the regular scripts, Python scripts that you would be processing. You can bring your own scripts for feature engineering and choose if you want to use the built-in containers or provided by AWS, or bring your own containers if you have specific processing that you want to do. Currently, for processing, the built-in containers include scikit-learn and PySpark and various framework processors that can run processing jobs with a particular machine learning framework, such as PyTorch or TensorFlow. The framework processors also has built-in containers for Hugging Face, MXNet, and XGBoost machine learning frameworks. All the resources which are created are created as part of the processing jobs. They're configured, run, and terminated automatically. So you only pay for the amount of time the processing job was running. Here's a picture to give you a sense about how the processing job is running. The processing job is running in a processing container that is running in an instance that is in the AWS cluster in your VPC. The input data for processing is mapped directly into a particular path in your processing container. And the output bucket is also mapped to a path inside your processing container so that your container can then ingest data, process those data, and produce the output automatically to be used as you see fit. So then let's talk about the SageMaker feature store. So as I mentioned before, SageMaker feature store is a key component of MLOps that lets you tie together the data that you were using in training to the data that you're going to be using for inference. So SageMaker Feature Store will take the results of SageMaker processing jobs or directly from Data Wrangler and store these into the feature store itself. Now the feature store has multiple benefits. It lets you, beyond the benefit that I mentioned of tying training to deployment, it will the feature store will let you share and discover curated features. It will let you standardize your features and reuse features so that you can minimize the amount of compute you need to do, and will also provide you with increased consistency. All features created by Amazon SageMaker Data Wrangler or other processing jobs can be stored in Amazon SageMaker Feature Store with a single click. And it's easy to update existing features or create new features. Amazon SageMaker Feature Store serves features in large batches for model training and also serves features with single-digit millisecond latency for inference at runtime. Because SageMaker Feature Store offers a central repository for model features, you have a consistent view of your features. In other words, the same features available for training are available for inference. So your features do not get out of sync. You can also visually search and discover features using the SageMaker Studio interface. All members of your team can share features into the repository, promoting reuse and eliminating rework, and so reducing costs. Feature Store also offers a unified set of feature definitions across teams, making it easier for teams to work together. So there are two aspects to Feature Store. There is the offline store. The offline store typically serves data for training. It serves data in batches. And then there's the online store. The online store keeps a small amount of data. Think of it as a cache. And it gets data and can obtain those data from the offline store. But the main part about the online store is it serves data um, with millisecond latency for rapid inference. So it serves those for model endpoints. Well, it can serve it to model endpoints, but it'll serve it to models for output. The offline store, as I said, is used for model training or batch scoring. Streaming data sources can automatically input data into online store using feature pipelines that you've created using Data Wrangler or your own code. You can also have batch data sources and process them through batch feature pipelines and add the results to Feature Store. Now let's turn to model training and tuning. So SageMaker provides what we call SageMaker training jobs. SageMaker training jobs consume data, typically from S3 or also from Feature Store. The training code is typically stored in an S3 bucket and is ingested by the SageMaker training job. Then the SageMaker training job puts the model result inside of a S3 bucket and also stores information related to the training that it's done as captured by SageMaker experiments. Amazon SageMaker reduces the time and cost to train and tune machine learning models without the need to manage infrastructure. With Amazon SageMaker, you can easily train and tune machine learning models using the purpose-built tools to manage and track training experiments and automatically choose the optimal hyperparameters. You can also debug training jobs and automatically monitor utilization systems of resources such as GPUs, CPUs, and network bandwidth. All steps of a training workflow can be automated so you can scale to thousands of training experiments. SageMaker also offers the highest performing ML compute infrastructure, including P4D instances, which provide up to 60% lower cost to train ML models compared to the previous generation instances. SageMaker automatically scales infrastructure up and down based on your training job requirements, from 1 GPU to thousands, or from terabytes to petabytes of storage. So you don't need to worry about managing infrastructure, and you only pay for what you use, so you can better manage your training costs. To make training faster, you can enable the SageMaker training compiler and immediately achieve up to 50% speed up through graph and kernel level optimizations, which make more efficient use of GPUs. Also, the SageMaker distributed training libraries automatically split models and training datasets across GPU instances to help you complete distributed training up to 40% faster. The key capabilities to train ML models are experiment management and automatic model tuning. Amazon SageMaker experiments let you track iterations to ML models by capturing the input parameters, configuration, and results, and storing them as experiments. SageMaker can automatically tune your models by adjusting thousands of combinations of algorithm parameters to arrive at the most accurate predictions the model is capable for producing, saving you weeks of efforts. You also can do debug and profile training runs. Amazon SageMaker Debugger captures metrics and profiles training jobs in real time, so you can correct performance problems quickly before the model is deployed in production. I've already mentioned distributed training. Amazon SageMaker makes it easy to perform distributed training by automatically splitting deep learning jobs and training datasets across GPU instances with fewer than 10 lines of code. There's the training compiler that accelerates training by up to 50%. It is integrated with versions of TensorFlow and PyTorch and SageMaker so that you can speed up training in these popular frameworks with minimal code changes. As for the question of cost, SageMaker provides managed spot training, which helps you reduce training costs by up to 90%. Training jobs are automatically run when compute capacity becomes available, are now made resilient to interruptions caused by changes in capacity. So let's take a look at your training options. So what do we have for training code that you have? You can use built-in SageMaker algorithm. Algorithm already brings in a number of algorithms that are prepared and can run out of the box to solve your machine learning problem. You have XGBoost. You can do matrix factorizations for recommendations. You can do regression, principal component analysis for feature reductions, k-means clustering, and many more. There's also, for example, algorithms to do computer vision, algorithms for doing time series forecasting, and algorithms for doing natural language processing. But if those algorithms aren't good enough for you, you can bring your own script. Amazon SageMaker builds the container open source algorithms. Brings the container for open source. So you can use Terrace, Keras, MXNet, PyTorch, Noravod, Gluon. Again, you can use XGBoost, LightGBM. You can use Spark. You can use any scikit-learn algorithm. You can use Chainer. But if that is not enough, you can also bring your own container for full control. You can build a container using R, C++, and so on. So you have fully managed, distributed, auto-scaled, and secured training. In addition to this, you can also find algorithms in AWS Marketplace for machine learning. There's a number of partners that put algorithms up in Marketplace and make them available to you for easy deployment into your SageMaker environment. A great feature that's been available for a number of years and now available in Amazon SageMaker pipelines is Amazon SageMaker Autopilot. If you don't want to deal with the trouble of selecting an algorithm for your particular business problem or selecting a training script, you can give your data to Amazon SageMaker Autopilot, and it will operate in one of two modes. One of the modes will be train and tune mode. It will automatically select amongst a wide range of machine learning algorithms and a wide range of parameterizations of those algorithms, the best result that you will get, the best model. You can also use the new auto glue on mode that will let SageMaker Autopilot automatically create a stacked model for you that will produce great performing results. So how is training handled in Amazon SageMaker? Let's take a look at what happens when you issue a training job API call. If you're familiar with SageMaker, then this is a refresher for you. If you're new to SageMaker, then this will give you an idea about what happens behind the scene. So the first step is to issue a training API call. In this call, you supply the information such as the EC2 instance type, container image, EBS volumes, as shown in the code snippet. So you put the information here as shown in the code snippet. We will look at this closely later on. When the SageMaker control plane receives this call, it's going to provide an ephemeral cluster of a single EC2 or multiple EC2 instances based on your configuration. This means that each training job request will have a dedicated EC2 instance. So if you have a few data scientists on your team or you're looking to train multiple models at once, you can do this. In both situations, SageMaker will spin up dedicated EC2 instances for each training job. You no longer have to wait for resources to be free. Now, some of you may wonder, will that be a problem? Because how does this control costs? Well, there are account limits that you can set, which throttle the number of instances that SageMaker can spin up for your training jobs. So you can avoid the sticker shock at the end of the month for having run too many training jobs. SageMaker control plane will spin up the EC2 instances and copy your training script on those EC2 instances. Then it will download the DLC image, the code image from the Elastic Container Registry. So for example, it could download a Hugging Face deep learning container. The control plane will also download your training data from the location you specified. You can download the training data from S3, from EFS, which is an NFS file share, or from FSX, which is a Windows file share. Once all the data is loaded, SageMaker will then start the training job. As soon as it completes, SageMaker will upload the training model to S3 and write the logs and metrics to Amazon CloudWatch. For those of you not familiar with Amazon CloudWatch, CloudWatch monitors your AWS resources and performance. Now, the key thing is as soon as the model is saved to S3, SageMaker will conclude the training job and decommission all EC2 instances provisioned for the training job so that you were charged only for the amount of time the training job was running. So now we've talked about Amazon SageMaker training jobs. The next step is to evaluate the model. And using the results of evaluation, apply SageMaker Clarify. SageMaker Clarify helps you detect if there's bias in your data that you use for training models or bias in the trained models. It also helps with explaining why your model made a particular prediction. So what exactly is bias in the model or in the algorithm? Well, if you've been following the news, there have been several cases reported where an algorithm made predictions that was far from the ground truth. For example, a high school administration decided to fire an exemplary high school teacher because an algorithm said so. So you need to understand what's going on in order to have responsible use of AI because the algorithm makes decisions. And so there were numerous cases of bias in facial recognition as well. For example, a Black MIT student was working on an art design project and found that her face was not recognized by the AI software. Whereas the same software recognized her face when she wore a white mask. That eventually led her into a crusade to fight against modern civil rights issues. SageMaker Clarify can also be used for regulatory and compliance use cases, where it can help you generate bias and explainability reports that you can share with your internal risk team. SageMaker Clarify integrates with every step of your ML workflow. As you prepare your data with Amazon SageMaker Data Wrangler, Clarify integrates with Data Wrangler and makes it easy to identify bias during data preparation. You specify attributes of interest such as gender and age, and SageMaker Clarify runs a set of algorithms to detect any presence of bias in those attributes and generates a visual report for bias on those attributes, such as, for example, through class imbalance. As you train, tune, and evaluate your model, Clarify integrates with those steps to detect bias in your model by providing Shapely-based explainability reports. Shapely gives you a sense of the Shapely values give you a sense of the importance of the various features to the decisions that your model makes. Changes in real-world data can also cause your model to drift, as we mentioned before, changing its behavior over time. Clarify integrates with the SageMaker Model Monitor to alert you if there is drift in feature attribution for model predictions. For example, a decline in home prices could cause a model to weigh income less heavily when making loan predictions. So now let's talk about SageMaker experiments. SageMaker experiments track every step of your training and in model deployment. So machine learning is an iterative process. You need to experiment with multiple combinations of data, algorithm, and parameters while observing the impact of incremental changes on model accuracy. Over time, this iterative experimentation can result in thousands of model training runs and model versions. This makes it hard to track the best performing models and their input configurations. With SageMaker experiments, you can automatically track the inputs, configurations, and results of your iterations as trials. With experiments, you can establish the lineage of your model, and that can help troubleshooting issues in production or auditing your models for compliance verifications or model governance. Now let's take a look at model registry, which is the glue between model development and model deployment. After training, you have a model artifact. SageMaker stores this model artifact in Amazon S3, which becomes your central model artifact repository. As S3 objects are immutable, you can further protect those objects with policies and versions, and versions. This helps you with model governance, reliability, and repeatability. SageMaker's model registry can then be used as a metadata store for your machine learning models that are ready for production. Your actual model artifact resides in S3 and is referenced in the model registry. After you selected your best performing model, you registered that model into the model registry. You set its approval status, and you also stored a number of metrics with your model and the experiment tie-in for that model. Once you move your approval status to pending approval to approved, you can automatically start a CI/CD pipeline for deploying your model to staging or to production. Model registry serves as a catalog for your production models, and you can manage your model versions here. You can manage your approval status and trigger approval workflows, such as CI/CD pipelines from the model registry. When I had mentioned approval status, by the way, model registry prevents the deployment of a model that has not been approved. So you can avoid errors such as deploying into production a model that is not ready. You can also associate metadata such as accuracy with your model and track model performance. So the main thing here is model registry becomes a registry of all models that are available for deployment to production. This will include model versions. It will include model metrics for each of those model versions. And you can share the models in model registry with other of your business units so that those business units can then decide to use a particular model that you made if it meets their particular business needs. So next, we'll take a look at SageMaker deployment features. One second here. So could someone tell me how I'm doing for time with respect to the clock?
You kind of have to be patient here because I have to like lower the volume on the speaker in the room and then turn on my mic here. So I apologize. We're due to take a break. I think at the bottom of the hour. Let me just double check here. Oh, 11:15. Yeah. So thank you. Yeah,
Oh,
11:15 is when we start the break. Then we go to 11:30. So I think if you're ready for a break now, we can just go ahead and do that. But the scheduled break is in.
Yeah, so unfortunately, but at least we're coming towards the end of the MLOps. We're going to be talking about model deployment, which is a key part. Model deployment into inference is the most expensive part of all machine learning that gets done. It's surprising, but it shouldn't be. Your model is going to make way more inferences in production than it's going to make during training. And so we need to pay particular attention to deploying your models using Amazon SageMaker. You know, if there's any one particular feature of SageMaker that I would point out as something that would be very good for you to use with your models, it would be SageMaker endpoints. And so we're going to take a look as to how to deploy models using SageMaker. Even if you use nothing else of SageMaker, you'll want to consider using SageMaker and its endpoints to deploy your models. For reasons of cost, for reasons of flexibility, for reasons of security. SageMaker offers managed deployment capabilities spanning multiple use cases and a variety of compute options to set your host model, to host your models on. You can use persistent endpoints for real-time use cases, asynchronous inference for near real-time and large payloads, batch transform for batch use cases, and serverless inference for spiky or intermittent workloads. In addition to those four main types of deployment offerings, there are capabilities within those like the ability to host multiple models behind a single endpoint. All of this without needing to change, but needing to manage the underlying infrastructure that is being used to host your model for predictions. So, for example, if you have a model that you'd like to use in real time, however, you don't use it often enough, so you think it's not worth your while to keep a deployed instance, but you don't want to go to serverless inference for various reasons. If you have other models, you can put all of those models in a single endpoint and then call each of those models in turn for your needs. And that way you can amortize the cost of that endpoint across your various models. Choosing the right deployment option along with capabilities within these allows you to choose the most performant and cost-effective deployment for your use cases. Also with MLOps, we're often looking as to how we can implement advanced deployment strategies when implementing new model versions. So there are capabilities that allow for A/B testing, canary or linear traffic shifting, and automatic rollbacks for minimizing risk in deploying new model versions. Finally, when used in combinations with SageMaker projects, um, you can implement continuous deployment and continuous delivery strategy for your model deployments. We don't have time to go too much into depth about the capabilities and features, but there are some great videos out there. Let's take a look at the SageMaker deployment options that I mentioned before. So there are two types of real-time deployment options. There is, of course, real-time inference, which is appropriate when you need to have millisecond results. And so your results in under 60 seconds. You need for this, for your payload size to be less than 6 megabytes. If your payload size is greater than 6 megabytes, then typically your inference will take longer than 1 minute to produce the results, at which point you should use asynchronous inference. Asynchronous inference is near real time. That's where you submit your payload and then later on receive your results. So you asynchronously submit your payload and later on you get your results. Asynchronous inference has a larger timeout than real-time inference. You can also use serverless inference. This is similar to deploying a Lambda function for doing inference, but serverless inference includes automatic scaling, so there's no need to select or manage servers. For workloads, it's for workloads that can tolerate a cold start. So if your inferences are bursty, that is, they come in packets of multiple inferences to be done at a time, the first inference will have a cold start delay, but then the rest of them will go through as if you were using real-time inference. So this is helpful for intermittent and unpredictable traffic. There is a limit on the maximum number of concurrent invocations per endpoint. And unfortunately, serverless inference is only supported for CPU. Finally, there is batch transform. That's when you need to process large chunks of data overnight, such as, for example, when you're going to be featuring data you recently obtained to store in Feature Store, or you're going to be outputting the results of inference into, or you're going to be outputting the results in inference uh, uh, into your data stores. Batch inferences are usually good for horizontal scaling. Each worker in a cluster can operate on a different subset of data without needing to exchange information with other workers. AWS offers multiple storage and compute options that enable horizontal scaling. So this, given the time, right, given the time, I'm going to skip the rest to allow you to go off on your break, but I'm going to point you to key resources that are coming up for MLOps. You can look at SageMaker MLOps resources and next steps you can take in our MLOps page, for which you see the QR code here and the URL here. You can also find additional resources for SageMaker and also for SageMaker documentation and SageMaker projects and how to create your own SageMaker projects. We have maybe a couple of minutes for questions. I'm willing to stay through the break if you would like that. Are there any questions? Thank you, Padma. A little personal note here. Years ago, I used to be a mathematics professor at the university level. And one of the things that I learned as a university professor teaching people is that when you ask for questions, it's good to have a long hang time, to be able to wait for people to formulate their questions and come through with them. If you don't want to speak your question right now, feel free to reach out to me. My email is shown here, or you can go through the process of reaching out to me um, in a different way. I've been talking for quite a while and I've been holding you captive for more than an hour and a half. So if this is the time for you to take your break, go ahead.
Thank you, Mario. I think our break time will start. And we
Super.
have
And I'll
a
keep my
15
eye
minutes
on the
break.
chat during the break in case people send questions.
Ich nehme heute keinen Roller mit, damit ich ihn geredet habe. Ja, also ja. Ich nehme einen Roller mit, aber ich kann dann immer kurz reden. So die ganze Zeit ist, du siehst doch nicht, nicht stören. Und jetzt nein. Das ist ich muss kurz halten.
Hey, oops. I wonder why that's going through there. Did you find any answers to that like group or organization question? No?
Mm,
No?
I'm sorry.
No, can you hear me now? 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 No, can you hear me now?
All right. I don't know how to disable this. Let's see. I'll just text you. It's very difficult.
Do we need a link for the survey?
It's a good idea because otherwise, you know, it's just difficult. Um, um, there's Mario.
There I am. Sorry, I wasn't hearing anything, so I didn't know whether people were back already or so on. So there's going to be, we're going to be entering the MLOps hands-on lab, and there's going to be this phase where we will be entering with the workshop event environment. That is unfortunately something we have to do. Is Joe there, Chris?
Yes.
Okay, so I'm going to assume that Joe will be handing out the codes since I don't have those codes, and I can walk through the onboarding process. I'd like to do that as quickly as possible. Is that okay?
Okay, so short answer is yes there. All right. Mario, just say a word or two. I just need to test the microphone here.
A word or two?
Perfect.
Okay. So I'm assuming that people are ready. Could we like have people raise the hands on the Chime chat to indicate that they are ready?
So just I don't know if we were explicit about this. So Joe, are folks to click on the link you just put in the chat and then enter the access code? Is that's
Yes.
the instruction? Let's be really explicit about what to do right now.
Okay.
Uh,
I think we have a presentation slide. I think Mario brought it up. Yeah.
Okay. I'm not seeing any hands go up. How are you guys doing? Are you guys ready?
Are you ready?
Okay. Yes, everyone's ready. Okay. Oh, there we go. Now
One
we're
hand.
seeing some. All right, the hands are
Yeah,
coming up.
when you raise your hand, don't lower it. We're trying to get a count. Thank you, Iman.
Okay, Iman is up. There we go. Should we join that? I'm not sure what that
Yes,
means.
please
Yeah,
raise
okay.
if you want to join the link, that's one thing. Please raise your hand that you're ready. That way we can provide instructions to everyone. Don't lower your hand, just raise it. So currently only 2 people are ready.
Yeah. Yeah, even you guys in the room, please raise your hand. No. I mean, oh wait, you're not on Chime. That's right. Oh, sorry.
The camera, how can the camera in the room to show there?
Honestly, well, when we go
don't know how.
upstairs, I think we'll be fine, but
I see. Yeah.
I don't know
There's some settings.
I don't
yeah.
know what's
It's
up
okay.
with the camera.
Don't mess it
here.
up.
Yeah.
Yeah.
And by the way, after lunch, we're gonna move to another room up on the 9th floor. I booked our sessions from 9 a.m. on, but I didn't realize that I was doing it on Pacific time. So that's why we had confusion.
Okay, so there were 19 people online, and right now 5 of them have raised their hands.
Okay, so if you're not ready, could you unmute and tell us what's happening so that we can help you?
I don't know how to raise my hand.
Oh, it's at the bottom of the chat. There's just a little palm right below the message to all attendees and the little paper airplane there.
I don't see that option. It looks like others might not either.
I see. The same on
For
Windows
me,
and Mac.
oh, hello. For me, when I click on the link, it's asking me to email one-time passcode.
Mm-hmm. So
So,
if you go to the Chime chat.
We
okay,
haven't started yet. We
Yeah.
just want you to be
Oh,
ready to
okay.
start.
Okay, there we go. Thank you, Joe.
okay, sweet.
I'm gonna go get my power cable.
Yeah, me too.
Joe, how many people are in the room?
Hi, Mario. Yeah, I have to unmute myself. Currently we have three, including me and Chris. We have five.
I'm wondering if it makes sense for you to step through, to show the slides and step through, since at least you'll have the people in the room.
Okay. Okay, I will show the step to log in. I need to. Take time. Can you hear me fine?
I can hear you.
Yes, we can hear you.
Okay. Sorry for the delay. Can you hear me fine?
Yes,
Perfect. Okay. I think Mario, are you showing the slides?
I'm stepping through as slowly as I can. I don't know who's following or whether people are following.
Okay.
I wonder if it's possible for you to share this getting started with workshop deck. I don't know if everybody share it as a PDF so people can just look at it and go through it.
Okay.
Have people been able to get on the workshop site?
I shared the workshop link. Let's click that link on the time. Maybe I can share my screen and show how we do it. How do you think that, Mario?
Yeah, I mean, by all means, if you could share your screen and show how to do it. Just remember, go slowly if people are trying to follow.
Here, though. Did not. Oh, I.
Kirti, if you're wondering which option to choose to log in, so a one-time password is fine, and that's a good way of doing that. Are you using your own account or?
Now I'm sharing my screen.
Thank you, I can see your screen.
Yeah. So when
How
you
did you
click
get
the,
here? You click the link?
so on the time, I share the link, Workshop Studio link, which has the catalog workshops, AWS, and join. So once you click that link, it will show you the website, which asks you to input event access code.
So, I'm sorry,
Now,
from the sign-in page?
copy this access code.
అరుస్తాడు ఏంది నేను ఒక్కటే చూసుకోవాలా వాడిని బాబా మీ కూతురు అది 4:30 5 వచ్చింది మాట్లాడుకుంటూ వచ్చింది వాళ్ళు వెళ్ళిపోయింది ఏంది నాకు పని లేదు నేను పని చేయొద్దా
Next, you will see the web page review and join. Click I agree. Then join event. Are you guys able to do it? Yeah. Perfect. Are we on the distributed training workshop now?
It's supposed to be that, yes.
Yeah. Okay. In this workshop, you can click the left side menu, which describe a little bit of the architecture for this workshop. And we have two parts. Today, we will focus on the MLOps on AWS, which is part 1. And tomorrow, we will focus on part 2. So when you go next, and it will show a page which tells you the prerequisite, basically the steps you need to prepare when you log into the AWS console. So keep this page open. And then also on the left side, you will see Open AWS console. This is the link for us to access Amazon SageMaker. So we can use Open Link in new tab. So this is another page we're going to use, which is the AWS console. Are you able to get that? Okay, access code is in the time chat.
Yeah, so everyone in the room here doesn't have the chime. I'll write it on the wall here. There it is. Ooh, it's complicated.
Yeah.
Wish there was a faster way to do this. But here we go. Maybe flashing on the screen. Yeah, just
Perfect.
put it
Yeah,
in
good
in-
idea.
yeah.
Okay. For the folks in the meeting room, The access code is this one, 46BC-04E697-61.
I think I can unmute the room. So mute yours.
Now, are we on the AWS console? Recall that on the left side, we have an open AWS console link. Open a new tab when you click it.
We're getting yes.
Are you able to get it?
Yeah.
Perfect.
Yes.
Perfect. Okay. So in this console, if you will find Amazon SageMaker. If you cannot, you can always go to the search and type SageMaker. Then click SageMaker. So I'm going to click it. Are you able to see the Amazon SageMaker now? Perfect. Okay, you might notice that here is a participant, okay, on the upright side. Now let's go to the studio. Click on the studio, SageMaker Studio, which is click on the studio on the left. You will see here is Open Studio on the right side, and the user profile is a SageMaker user. Now let's click Open Studio. Are you able to do that? Perfect. Now we are into SageMaker Studio. When you click the directory on the left side, which is a file browser, you can see here is an empty folder. That is where we're going to upload our source code for the lab later. Are you able to follow? Perfect. Okay. Now let's go back to the workshop and follow the prerequisites. So first we download the zip file to a local machine. And then we go back to the SageMaker Studio. On the top left, there is a upload files. Then you upload the local zip file. Here's the lab phone for me now, but that's the zip file that we just downloaded. Upload that file. So because here has a different name, I'm gonna rename my zip file. You should have a interface like this now. Are you there? Okay, great. Now let's go back to the workshop studio.
Hold on a second. Someone's saying here that zip files cannot be allowed according to their company policy. So can you drop it into chat or
Okay.
chat there?
I'll drop it in the chat. Yep, that's good catch.
It's 2 meg. That's nothing these days.
Okay. So first I put in my desktop and I want to rename it to the right name.
There we go. Someone else did.
Oh, somebody did it?
Yeah.
Okay, thank you. Okay. Now let's go to the terminal to unzip the zip file. Go to New Terminal. And we can list, that's the zip file we have in the current directory. And go back to the Workshop Studio and copy the code, which is to install the unzip and unzip the file. Copy that and paste it in the terminal.
Sorry, I cannot see the option for the terminal.
Could you repeat that, Mario?
Now you will see 2 folders are under the current directory. One is SageMaker
I cannot see
end-to-end
the
MLOps labs, and one is SageMaker digital training labs. And today we will focus on the end-to-end MLOps labs. Then double click it. And you will see some Jupyter notebooks under this directory. Any questions? Cannot see the option for open terminal. Okay, let me show you how to open a terminal. Go to the file, go to new, and you will see a terminal here. Okay, unzip. Okay. Once you go into the terminal, which is this one, you go to the workshop studio that we opened. And you scroll down, you will find some commands to run in the terminal, which is this two. So the first command is to install the unzip. And the next one is to unzip the zip file we uploaded. Yeah. Let me see, are there any other questions? Okay. Not seeing the file menu. Not seeing the file menu.
Maybe they're not in SageMaker Studio.
Okay. So are you going to the studio and the open studio? Padma? Are you opening the SageMaker Studio? Okay. Yet.
I can open the terminal, but I cannot write anything on that screen. It is visible for me.
It's the first part. Okay. I will hand over to Mario to explain and demonstrate the Jupyter notebooks.
Okay, how is everyone? Yeah, sorry, this is the most painful part of any workshop, getting into the event. So let me see. Do people see my screen? Yeah. Okay. There should be a bar on the left-hand side that lists notebooks 1 through 8. If you don't see that bar, go to the toolbar here and click on the folder that will open the listing of files. In fact, you can click and unclick to open and close that. So, given that we've spent most of the time of the workshop doing this, I'm going to paste a link. That link in the chat, if you could go to that link, that link happens to include instructions to a workshop very much like this one, with many of the same steps. And given that we only have 23 minutes left before the speakers, we're going to have to give you the chance to be able to continue the workshop on your own. As you may have seen, your account in the workshop will be able to last until 3 days from now. So you'll have time to go through this on your own. So once you have the listing of notebooks, I want you to pick the one labeled number 1, which is SageMaker Data Prep, and double click that. Now, for your case, it won't say starting the notebook kernel. Instead, it's going to say this. It's going to offer you set up the notebook environment, set up environment for this notebook, image, data science, kernel, Python 3. What you have to do is basically just click select. This is going to happen every time you open a notebook for the first time. So just click select, and then it's going to start the kernel. So as you see, this is the data science kernel, Python 3, 2 vCPUs. You'll find in every notebook at the very start, the first cell of the notebook has this command in it. Its purpose is to make sure we have the latest version of SageMaker. In order to execute this line, there are many things you can do, but the simplest thing to do is to hold down the Shift key and press return. And then there's a lot of text that will come in underneath. So basically, I went into the cell, held down the Shift key, pressed return, and then the cell executed. So now let's start going down the cells of this notebook. The purpose of this notebook is to prepare data files that we're going to be using in the other steps. The other steps of the notebook after data prep will be to train a model, register a model, deploy a model, and then take what we've learned in order to construct the SageMaker pipeline. And after we've been able to construct a SageMaker pipeline, we're going to go back and learn how to do data quality monitoring, model quantity monitoring, and then understand the lineage of the model that we've created. Okay, so at this point, you should be at this cell. The cell is simply a series of imports and initializing a number of key variables: session, default bucket, bucket prefix, the execution role, and the region in which you are working. Generally, these sorts of information is needed to be able to get clients, photo clients, such as in the next line. So let's say we press enter, shift enter on this. Ooh, I've never seen that one before. This is cute. I just got an ad in my notebook for something to do. So I'm going to leave that aside for the moment. I think this is AI getting the jump on us. All right, then you should be on the following cell that creates the Boto session and SageMaker client variables. Press Shift Enter on that. Then the following line creates a directory called scripts. You shouldn't have one yet. Once you run this line, you will have one. I already have one because I've already run this before. And we're going to be writing a file into the scripts. This file does the pre-processing for the data in our workshop. So this is what this file magic does at the top. It says, I'm going to write a file in scripts preprocessing.py. And what this particular preprocessing script does is it introduces a preprocess function that will manipulate the data and create features and remove features we won't need, and then get dummy variables for categorical features. That's what that function does. What the script does, the part after if main, is it reads in the file that we need, which will be input bank data additional. Then it does it processes that data, splits it between train, validation, and test, and then writes train, validation, and test. So what this script is doing, if you remember when we were talking about the processing, SageMaker processing, I mentioned that there would be this OPTML directory that will be where your input data would be found. And then there would be OPTML processing output, where the output was going to go. So basically, that's all things that you do with your code. So let's press Shift Enter on this cell so that it will overwrite, well, for me, overwrite, for you, write the script for the first time. If you wonder where the script is, you can go to the scripts folder and look inside. Let's not do that now. Then let's get the data that we need. We have in our folder bank additional fold.csv. We're going to upload that using a SageMaker client. We're going to upload that to S3. Press Shift Enter on this line. So now we've uploaded our data in a location on S3. The location is the session's default bucket in a folder called marketing. It's not the kind of folder you would see here. It's in S3. So now what we do is we create an sklearn processor object. We're going to use that to run our script. So sklearn processor needs to know what framework version you're going to use. In this case, we're using an older framework version. That's fine. It needs to know what instance type to do the processing. So here we're using one of the ML instance type, ML M5 X large. We're only going to need one of those. And we're going to name the job that we're going to run sklearn marketing process. This sklearn processor needs to have a role because it's going to act in your stead. So it needs to have that role in order to know have the permission to do things. And it needs to have the SageMaker session. This is all cool. So let's press Shift Enter. Then we come to the following line. Now this line is going to use SageMaker processor and is going to run it. What will it run it on? It will run it it will run our code, the script preprocessing.py that we created before. And here are the parts that get mapped in, the inputs and the outputs. And so this says we would like to map the input data that we uploaded to S3 a few steps back. We're going to upload that into OPTML processing input. Then we expect the script will produce outputs. It will produce one output called train. We'll need the names later to work with that, but output called train, and it's going to find that inside of OPTML processing train. And the same thing for validation and test data. If you can go back to the script, you will see that's basically what I did in the last 3 lines. I created the output files. I wrote my train data frame to train CSV, validation to validation CSV, test to test CSV. So let's come here and press start, press shift enter. And then what's going to happen? Well, it's what we said before. An EC2 instance gets allocated to run that script. It's not run locally. You could have run that script locally, that's always possible, but we're trying to do this remotely. So this script gets allocated, and the instance gets allocated. It's going to take a number of dots for it to be allocated. It's going to take just a few minutes. And the dots are actually the counting of the allocation of the EC2 instance. It's not yet running the script. It takes a while to allocate an EC2 instance. Okay. So the line that follows, by the way, will let us pick up where the data have been put. So let me read this. And first, we're going to use our sklearn processor that we used to run. We're going to ask it what job it had, -1, the latest job that it ran. We're going to ask it to describe it because we're going to pick things out of the description. So we save that description in processing job description. And then we pull out processing output config, outputs, output 0, the S3 output, S3 URI. So that's going to pull out the train URI. That's where when it ran the sklearn processor, it copied the train data, it picked up the train data the script wrote out, and it copied it into S3. So we're reaching here and we're putting it into this variable train URI, val URI, and test URI. Once we have these, we're going to use Jupyter Cell Magic called store that will let us create variables we can use in other notebooks. So it'll tell us, it'll save for us the name of the variable train URI and its contents. Same for val URI and test URI. And then we'll continue from this and we'll take a look at the data. So as you see, it takes a while for this ML M5 X large to be allocated. It's a CPU instance. Could somebody who is following on this please speak up so that I know that you're following? You can unmute and speak.
Yeah, everything seems to be working pretty well. I mean, at this point, I've processed through this entire first section, so it does execute.
Thank you, Genevieve. Is that how you pronounce your name? Or do you say
Yeah,
Genevieve? Okay.
technically Genevieve, but you can just say Jen.
Jen, sure. Thank you, Jen.
Hmm.
All right. So as I said, it takes a few minutes for an EC2 instance to get allocated. Have other people? Okay. Thank you, Vijay. You can see the output, so it's working for you. That's cool. So I'm assuming here you're telling me, Vijay, are you saying that you've passed the step that I'm waiting to have finished and you've gone down to view the process data?
Yes.
Thank you, Vijay. I
Yeah.
appreciate that. So a quick question. Well, I should have asked this in advance. Let's not ask any questions further. It's taking a long time, much longer than usual, to allocate this EC2 instance for me. And it is, oh, good, it's finished after 5 minutes. Okay, so it's finished. So now I'm going to capture the processor output, the job description. Then I'm going to capture the URIs that tell me where the train, val, and test data are stored in S3. Then I'm going to use cell magic to create stored variables. That's cool. So now we can go and take a look at those data. So what are we doing? Well, this line will copy the train URI data, train CSV, into a temporary directory. It's going to download that. Let's press enter, it downloads. Then let's load it into a variable using pandas. Pandas will read the CSV and load it in. And then we can see the head. Now you'll notice there are no variable names with this. That's okay. So typically when there's no variable names like this, usually one of the first columns or the last column is going to be the target. But we can work with that later. If you've gotten to here, then you're ready to move to notebook number 2, when we're going to train a model. So go to the here, double click the notebook and open it. As I said before, each time you open this notebooks, it's going to ask you what kernel you want to use the first time, and then it'll just know what to do. So for me, it doesn't ask me because I already told it. All right, so I'm going to do this pip install that everybody has. And once that is run, and it has, then I'm going to do this setup cell that we had before. Then I'm going to use cell magic to get the variables that I had saved before. And I'm going to take a look at them. So I'm pressing Shift Enter on each of these cells. And now I see where they got stored and their names and so on. Okay, so now we're at the case for training. Now, training is a lot like processing, except it runs machine learning algorithm. So this machine learning algorithm needs to have a container image. The container image contains the algorithm and all of the information that you need. And this is what this cell is going to do. What this cell is going to do is it's going to get a pointer to the XGBoost, latest XGBoost algorithm framework that's available in our region. So Shift Enter that, and we get a pointer to that, which is cool. And then we're going to start tracking the job in an experiment. So let's talk about experiments. Experiments are collections of runs. Each time you run the training job, you will have a new run, but you will tend to gather them inside of an experiment. Each run will produce its own output. It will create its own model. So you can go take a look at that run and examine it. But the experiment will know for that run what are the values. So let's go run the first cell here. So it'll be possible for us to take a look at the jobs that are executing inside of a control panel. So this is what this is explaining. It's possible for you to track your training job at a run. So we're going to do that in a moment. We're actually going to create that run to begin with. This is what this cell does. This cell brings forward an estimator. You need the estimator to run the algorithm that we got from the image URI up above. We're going to run it on an ML M5 extra large again. We're going to use only one of these. We're going to store our models where? We're going to store our models in our default bucket. It's a place for our experiment. We're going to call it XGB model. So we're going to start that there. That's the model path. And as before, it needs the role, our SageMaker session. We're going to allow it to only run for an hour at most. It's not going to take that long. And then we're going to use a form to do the hyperparameter tuning. We're going to do this run. We're going to name the experiment that we called MLOps workshop experiment. It needs to know what session it is. And we're going to name this variable run. And in this environment, we're going to do our XGB training with binary logistic regression, 50 rounds, depth of 5 trees, and some of the other parameters. So those are the hyperparameters for that run. Then we're going to say fit. When we say fit, we're going to have to pass it the training data as input and the validation data as input. So we use this construction called training input. So we create this dictionary. First value is training input. And we say the data is in the train URI. And we say this is a CSV. So we do the same thing for validation. So just press Shift Enter on this cell. And it's going to go create the training job. Now, as before, in order to do this training job, it has to allocate an EC2 instance for you to do that. That's the NL M5 extra large. So this will also take a little bit of time. And again, the time is counted as the dots. So you will see that it takes a while to allocate the instance itself. And then very quickly, the script will run and it will produce its results. It allocated the instance, it's preparing it for training. And dot, dot, dot. So let me take a look as to what's going to be happening after this is done. After this is done, we're going to create 2 new variables. One of them will be the model data location and the training image that we used. We're going to save these because we want to use them later. So currently it's downloading the input data into the input location in the container. It downloads the training image. That's our XGBoost training image. And there, zoop, it did all the work. So as you see, setup takes a while. So it's going to say train error, and that's the training error, that metric, and the validation error, that's the validation metric. It doesn't mean there's been an error that's happened. Okay, so it's finished this. So let's grab the model data. Instance not retained as a result of worm pool. Limits being exceeded. Okie dokie. And it tells me that this took 83 seconds. You'll notice most of that time was in actually allocating and setting up the instance itself. The training itself went very quickly. So now we execute the next line to grab the train model URI and the training image, and we're going to store them so that we can pick them up in another notebook. Okay, and now it's 12:30. Chris, what are we doing?
Chris is in a call, and now it's 12:30. Based on our schedule, it's lunchtime.
Okay, so what I'm going to do, I've pointed people to these instructions here. Welcome to this Amazon workshop. So the instructions here take you through information on what to do. Module 1 is basically what we just walked our way through. Module 2 will be the creation of a pipeline. So we haven't done everything here. We've prepared the data, we've trained the model. Then this will have the instructions for notebook number 3, put a model in a model registry. And after you put a model in the model registry, you'll deploy the model for inference. That'll be cool, and that'll take you to notebook number 4. Then we'll start module 2 for the automate the ML tasks, run the pipeline to deploy the model. Well, that's not going to actually work out that well. That's actually in part to create a SageMaker project to do the job. And we're not dealing with SageMaker project in this workshop. So you're simply going to create a pipeline. We're going to be using this to create a pipeline to deploy models, and we're not going to use projects to do this. Does anybody have any questions? All right. So I had told you that we could see other things in here. So let's take a look at notebook jobs. This is the notebook that I have. Notebook jobs, there are none. Experiments. That's right. We just ran something with an experiment. This is cool. We ran MLOps workshop experiment. So what I did is I went to the home tab, the home blade, and in the blade, I went down and I said, experiments. What are your experiments? And so I went here and I found that I've got 3 experiments in this account. That's okay. This is the one that we just worked with, MLOps workshop experiment. So open this up. When you open this up, you'll notice that there are a number of runs that have been made. These particular runs have been made. One of them has been done now, and others were done. Let's see, this one was done 2 days ago. This one was done today. So this top one and the bottom one were done today. What are these runs? So let's take a look. There are no metrics that were saved with this run. So let's just close this, go back to workshop experiment. Let's look at the XGBoost run. Cool. XGBoost reported its metrics. So this is very good.
So Mario, we
Yep.
only have 30 minutes for lunch.
I know. I should let you guys go. Have fun, and you
Yeah.
have the instructions. And Joe, if you could make sure that everybody has access to these instructions, this should not be a big issue. This is a standard workshop. I'll paste it again here.
Wonderful. Mario, today the lab will help us prepare for tomorrow's distributed training.
Yes,
So,
hopefully you will have faster setup than what I have.
yeah, wonderful.
Yay. Thank you.